Welcome to section 12.3. We are dealing with today geometric sequences and series. So I want to start first with getting the idea of what are we trying to do. Biggest thing that I need you to know, when you're talking about geometric, and this is kind of the main idea, we want to talk about multiplying by a constant number. Okay, and that's the biggest thing in terms of what is geometric and how does that work. And then what you need to know is that basically we're multiplying every time by a constant number. Positive or negative doesn't matter, it's just a multiplication. And so as we go through, basically what we're going to find is that if I take the ratio, which means I divide two terms, what I'm going to find is that I get this idea of a constant number. And so we have this thing called a common ratio. That means if you divide the third term by the second, you get a number. And the second term by the first, you get the same number. We call that constant ratio R. And they give us this equation for our geometric sequence. And this is similar to the idea that we did in arithmetic, where you look at the first term times the ratio to whatever term you're looking for minus 1. And so we're going to work with this for a little bit. Now, as you take a look, let's talk about this. A sub n equals a sub 1 times r to the n minus 1. And I'm going to put it up there at the top so we can kind of see it. Now, in number 1, they're going to ask you for a rule. The rule just means what is the equation. Well, if I'm looking for the nth term, I always take my first term, which is 12, times my ratio, so times 3 to the n minus 1. Well, that was really easy because they gave us the first term in r, so it wasn't a big deal. Well, if I want the nth term, then all I have to do is plug in a 9. So a sub 9 is 12 times 3 to the 9 minus 1. Don't forget parentheses around your exponent. What you end up getting, though, when you plug it in your calculator is 78,732. You are going to get very big numbers. Please be okay with that. Okay, now take a look at 2. Here's what's different. I don't give you the term or give you the r, but I do give you the first term. And the negative 108 here is a sub 1, our first term. But our goal is to figure out what is r. In order to find r, we take the second term divided by the first term. We get negative 1/3. Now, you can't just assume that's going to work, so we're going to do another one just in case. We could take the third term minus the second, or divided by the second term, you get negative 1/3. You want to make sure that this ratio is the same, and if it is, then our ratio is negative 1/3. Well, now that I know my ratio and I know my first term, I'm going to write my rule. So the nth term can be found by taking negative 108 and multiplying by negative 1/3 to each term minus 1. So there's our general rule. And again, you're always going to write a rule, then they're going to have you find a term. In order to find the term, the 9th term is negative 108 times negative 1/3 to the 8th. Because it's the 9 minus 1, you end up, when you're done, you're going to get a decimal. Do me a favor, hit math fraction. You get negative 4 over 243. Okay? So if they don't give you the ratio, you can easily find it by dividing terms. And you just want to make sure that when you divide the terms, you get a constant ratio. If you don't, then it's not geometric. All right, so let's keep moving. We want a rule for a geometric sequence. If r is 3, and it looks like we're missing something, we want to tell you that the 5th term, and I don't know why we're missing that, but the 5th term, we want to give you a value of 54. We're also telling you r. The problem is I can't write a rule until I know the first term. So here's what we're going to do. We're going to use our general equation, and I'm going to use some work, so if you need some more space, please be aware of that. I'm going to start by my general rule. The first term times r to the n minus 1. Well, let's talk about what we know. Well, I know r is 3, so I'm going to plug that in. I also know a 54 is my fifth term, so I'm going to put a 54 equals. I don't know my first term, but I do know that the fifth term, so this is n, is 54, so 5 minus 1 goes in the exponent. And again, this gives you your n, this gives you your whole a sub n. So it's kind of filling in the blank type idea. So as we look at it, here's what I'm going to do. 3 to the 4th power is 81 equals 54. So I'm going to divide both sides by 81. And when I reduce my fraction, I get 2/3. Well, now that I know my first term and I know my r, I can write an equation. A sub n equals 2/3 times 3 to the n minus 1. Here's my general rule. Once I find my general rule, I can then find the 15th term. And in order to find a sub 15, I'm going to take 2/3 times 3 to the 15 minus 1, or the 14th power. You end up getting 3,188,646. And again, it's okay to get big numbers in this section. Please do not be afraid of that. So there are going to be times when we give you one term and the ratio, and you're going to have to figure out the first term. We did an example where we gave you the first term and the ratio, and you just wrote your equation. Guess what? We're going to go a little harder. We're now going to give you two terms. The third term is negative 48. The sixth term is 3,072. Now I'm going to walk you through, I'm going to call it a 4-step process, but we'll kind of figure it out. Here's what I'm going to do in the first part. I'm going to write an equation for each term. So this first term will say negative 48 equals the first term, I don't know r, so times r, but since a sub 3, I'm going to say 3 minus 1. So this is really negative 48 equals a sub 1 times r squared. Okay? I'm going to write a second equation for my second term. So 3,072 is the first term times r to the 6 minus 1, because this is the sixth term. So really 3,072 is the first term times r to the fifth. Okay, I have two equations. Yesterday we did this idea of elimination in order to find those missing pieces. Because we have multiplication, we can't use elimination. So we're going to use substitution. And so what I'm going to do is start with the lowest exponent and use substitution. So I'm going to take this equation and I'm going to find a sub 1. Okay, the first term. So here's how it works. I have negative 48 equals a sub 1 times r squared. If I want a sub 1 by itself, I divide by r squared. So a sub 1 is negative 48 over r squared. Once I found a sub 1, I'm going to take this and I'm going to substitute it into my other equation. So 3,072 equals negative 48 over r squared times r to the fifth. And I'm going to write r to the fifth over 1 because I'm hoping that you'll see I can use my exponent rules here. One's on top and one's on bottom, so I subtract the exponents. So 3,072 equals negative 48. 5 minus 2 is 3, and since the 3 is positive, it stays on top. So I divide by negative 48, and r cubed then equals negative 64. And if I cube root, to get rid of a cube, you cube root, I get that r is negative 4. So I found the first part of my equation, but in order to write the equation or the rule, I have to have both the r and the first term. So I'm going to put the r back in, and I'm going to say, all right, negative 48 over negative 4 squared. So negative 48 over 16, a sub 1 equals negative 3. Now that I know these two, I can write my rule. This is, in my opinion, the hardest question from the entire lesson. And I will give you another question like this in the warm-up for tomorrow. But my rule is, my first term we decided was negative 3. My ratio is negative 4 to the n minus 1. Now, you can use that to find the 15th term. I'm not worried about taking the time there. But I promise you, you will have this on your quiz. Plan on it. You want to talk about a heavy question on a quiz, that's it. We will talk about it in class again, but you've got to know how to do this. Okay? If you flip to the back, we're talking about finding the sum. So instead of finding specific terms, I'm now going to ask you to add up some terms. Okay? And that's what I mean by finite. We want you to add finite. We want you to add a specific number of terms. In order to find the finite sequence, it's geometric, so we're going to have the multiplication. This is the formula that we're using. Okay, so here we go. I'm going to put that formula back up there. The sum of n terms is the first term times 1 minus r to the n over 1 minus r. Okay, so here we go. We would like you to write the first terms and then add them together. If I look at my general equation, this was always my first term, this was always my r. So I'm going to start at 1. My first term is 2. In order to find my second term, so this is when I equals 1. I equals 2, I equals 3, I equals 4, and I equals 5. That's what this summation means. We talked about that yesterday. But taking a look, this says multiply by 3 every time. So if I have to multiply by 3, then I'm going to take 2 times 3, I get 6. 6 times 3 is 18. 18 times 3 is 54. And 54 times 3 is 162. You don't have to plug in the numbers if you understand what the problem is asking you to do. If I add these up together, I end up getting 242. Okay? Now, if I were to use the formula, here's what I would say. My first term we said was 2. 1 minus, my ratio was 3. And because I'm going up to 5, we say to the 5th power, all over 1 minus 3. Put that in parentheses as well. You still should get 242. If you don't, we got to figure out then what we're putting incorrectly into our calculator. Okay? Let's try another one. Now, if you look at this, the question is, do you want to start up at 1 and then go all the way to 16? You could find all 16 terms and add them together, but you would be wasting your time. So let's talk about formula. This 4 is my a sub 1. This 3 is my r. 16 is my n because that's as far as I want to go. Here we go. In order to find this, we take the sum of 16 things. So my first term is 4 times 1 minus 3 to the 16 all over 1 minus 3. Again, put it in an extra parentheses. It's okay to get a big number. What you end up getting is 86,093,440. Seriously? Perfectly fine. Okay? The last one in this part that I want to talk about before we kind of talk about story problems is this idea here of what if I don't start with 1? The formula that they give you only assumes that you go from 1 to your number. And so the way this works is we're going to have to take the sum up to 15 and get rid of the extras that we don't want. I don't want 1 through 4, so I'm going to take then the sum of 4 and subtract it out, because that's the part I don't want. And this is the easiest way to do it. Now you could find 5, plug in a 5, get a number, 6, 7, 8, and all the way up. But in my opinion, it's just not worth it. So if I do the sum of 15, I'm going to set it up for you, and then I want an answer when you come to class. If we look at this, the sum for 15, here's my first term, here's my ratio, here's my n. All right, so here we go. 800, 1 minus 1/2, I would stick that maybe in an extra parentheses to the 15th, over 1 minus 1/2. You can use 0.5 if that makes it easier to put in your calculator. That's perfectly fine. Minus, let's do it again, 800, 1 minus 1/2 to the 4th, all over 1 minus 1/2. And again, I have to go to the 4th because I don't want the 4 to be included. I just need to get rid of 1, 2, 3, and 4. Okay, so here's what I want you to do. Find me the answer. When you come to class, I want that answer. But that's really going to tell me if you can get it in your calculator correctly or not. Okay? We also talk about this idea of find the sum of the first 22 terms. Here's the hard part. I know the first term. What I don't know, though, is the ratio. And I need that ratio in order to be able to add these up. And so how did I find the ratio? Well, in order to find the ratio, we do the second term divided by the first term. You get 2.5. To verify, 25 over 10, you get 2.5. 62.5 over 25, you get 2.5. As long as you're getting the same number, here's our value of r. Now, if I know the first term, and I know my r value, they've told me how many terms I want to add up, so they told me what n is. All I have to do is plug in the formula. The sum of my first 22 terms is 4 times 1 minus 2.5 to the 22 over 1 minus 2.5. Stick that guy in parentheses. What you end up getting is, let's give me a number, 151 million. Oh no, not even worse than that. 1,515,824,500. It's a big number. Okay? I like this one because it doesn't automatically give you some things. You had to find it first. You will see those come up as well. All right, let's talk story problem. In 1990, the revenue for movies was $5.02 billion. From 1990 through 2003, the box office increased by 5.9%. Guess what? That's our R. Hey, guess what? Here's my A sub 1. Write a rule in billions. Because all of our values are in billions, we're going to leave it there. A sub n equals my initial term. Now, we want to change our percent to a decimal. And because it's increasing, we want to say 1 plus 0.059% to the n minus 1. Now, if I write this out, let's do this a little bit different. 5.02 times 1.059 to the n minus 1. I like this one a little bit better because I don't really want to see the plus or minus. But you saw increasing, so you do 1 plus. That takes us back to chapter 7. So it's coming back. What's the total box office revenue for 2000? The question is, what year is that? 1990 is when I started, so 2000 means our year 10. You plug it into our formula. What do you get? 8.41, don't forget a label, billion. Okay, probably need a $sign in there too. Last one, what's the total? Well, how many years am I looking at? This is 13 years. So I want the total in 13 years. So I start with 5.02. 1 minus, there's my R, there's my A sub 1. So 1 minus 1.059 to the 13 over 1 minus 1.059, and you get about $94.18 billion in sales. Would have liked to own a movie theater, huh? Okay, so this is kind of the idea going through. I actually want to leave. There's another example that I want to talk to you about bouncing balls, but we'll do that tomorrow in class. So that's it for 12.3. Thanks for watching.